Well, hello everyone. Welcome to our first video for the Math 140 online course. What we're going to cover in this video is section 1.1, and I'm going to do this video in 4 segments. So with no further ado, let's go ahead and get started with the lecture. So now what you'll notice is that there is a link in eCampus that you can download a similar file to what I'm sharing on the screen. So you should be able to download and print off a PDF version of the notes as far as what I'm going over here. So that way it helps you follow along as we go through things. So the first thing that we're going to cover is obviously section 1.1 from your book. This is just the first video, and what this video is going to contain is just a review of linear functions. So let's see. So linear functions, remember, are straight lines. That's what so the word linear is meaning a straight line. Function we'll talk about a little bit more as we go through the course, but a linear function or linear functions are straight lines, and the steepness of the line is measured by what we call the slope of the line. In math, you may remember that the slope of the line is the measure of the vertical change divided by the horizontal change. So it's how far you change by going up and down versus how far you change by going right and left. You may know this as rise over run, or this did not come out very good here. This should be right here. It should say delta y, and I think in your notes, hopefully it printed off correctly, but it should be delta y over delta x, where delta means the change in. Okay, let's look at this concept in GeoGebra. So in your syllabus, I noted that we would be using an online software that's actually really cool. It's dynamic and gives you lots of different visuals to go by. So let's look at that in GeoGebra. Okay, there we go. Now I think it's actually coming up on your screen. What we want to do here is always click on GeoGebra Classic right down here. And when we click on that, it's going to open the GeoGebra interface. So you'll see there's lots of different things. You can do calculations, we can do graphing, a lot of different things. I'm going to close this bottom part out down here. And then I'm also going to grab these crosshairs so that I could move this a little bit into our viewing area better. You'll also notice that you can zoom in and zoom out with this menu. So I would highly encourage you to just play around with this particular interface. There's nothing you can really do to hurt anything in here. You just clear it out and get a new one. So the first thing I'm going to do is click right here, and I'm going to get a point, and I'm going to plot a point somewhere. So that is actually the point over 1 up 4, and you can see that over here. It says the point 1, 4. I'm going to keep this point icon highlighted, and I'm going to let's just put it right over here. So I'll put it at 4, 7. Feel free to follow along as we go through here, or you can pause the video so that you can do the same exercises that I'm doing here. So those are the points A and B. A is at 1, 4, and B is at 4, 7. Now to create a line that goes through those two, I'm going to click on this menu and get the line tool. And then all I'm going to do is click on A, and then I'm going to click on B, and it graphs me a nice line. Over here, you'll notice it gives you the actual equation of the line, and we're going to talk a little bit more about the equations of the lines here in just a little bit. But what we're interested in right now is the slope. So remember, we had talked about slope. So right here, I'm going to type in slope, and you see it gives you a little hint as to what you need to actually put. So I need to put the slope and then a parenthesis, and now I need to tell it the name of the line. And you can see right here that when I constructed the line between A and B, it named my line F. So I'm just going to put F right in here and then hit enter, and it tells me the slope of the line, and it also shows me it right here. Now in GeoGebra, it's always going to have the when we do it in this format anyway, the horizontal change is always going to be 1, but you'll notice that the vertical change will grow or decrease, whatever it is. So oops, I didn't want to do that. So if you do that, what I just did, which was plot a bunch of things I don't want, I'm going to come over here and grab this arrow tool, click on the line, and I'm just going to hit delete button on my keyboard. I'm going to do the same thing over here to get rid of those things. I did not want those. I wanted this selection arrow. And now what I can do is I'm going to click and hold, and click and drag on this point B. And what I want you to do is watch over here and see what happens to the slope. So I'm going to make this steeper. And you can see that the slope gets bigger and bigger and bigger and bigger as this stays a positive sloping line. So you can tell that the horizontal and vertical, so the vertical changes 3.15, the horizontal changes 1. That's why the slope is 3.15 over 1. All right, so you can move this to see what the slope is. As it gets bigger, you see the slope increases. As it gets steeper, the slope increases. I can make it all the way straight up and down. And you see that the slope is actually a really large negative slope. Oops, sorry, I didn't mean to do that. Sometimes that's just because of the computer, but when it should say undefined somewhere in here. I might not be able to get it to do it exactly undefined, but if it's vertical, it technically is an undefined slope. We don't know what the slope is. It's kind of too steep. If you notice, if we put it flat, that's where we have a zero slope. So no slope means zero slope, which means flat line. Totally vertical line is undefined. And I know that GeoGebra will do that at some point. It will tell you undefined, but in the instance that I have right here, it's not going to actually do that. So here's positives, steep positive, kind of a flat positive. Here's zero. And now if I bring this down here, you'll see I have negative sloping lines. So this is negative 0.55. So not a very large sloping negative line, and we can just make it more negative here. So that's what the slope of the line is. It just tells me how steep am I? Am I a positive and kind of steep, or am I really steep? Do I have no slope, so I'm completely flat, or do I have a negative slope? And then how steep is that negative slope? And then if it's too steep, if you, oh, look, there we go, it's undefined. So the pixels in the computer must have hit it just perfectly. So that's what we're going to talk a lot about, is slopes of lines, and then this equations of the lines. So this equation is x equals 1. It's because it's a vertical line going through the x-axis at 1. If we go this way, you'll notice that this one has an equation of, let's get the slope to be exactly 0. Your guess should be that it should be at y equals 4. A little bit kind of crazy over here, so we can't always depend on calculators, but that should be at y equals 4. And then you'll notice the equation of the line changes as the slope changes. So that's the next thing that we're going to talk about actually then, is these equations of lines. So let's get back here to our notes and look at this. So we looked at the concept of slope in GeoGebra. Slope is only for lines. And it is the measure of the change in y over the change in x, or as we said earlier, it was rise over run. And I'm going to write this again right here just so that it's correct on the screen one more time. This would be, well, maybe I'm going to write it right. So this should be delta y over delta x, change in y over change in x. Okay, so let's look at example 1 here. So if we have the slope, I want to find the slope of the line containing 5, 3, and negative 10, negative 6. So first thing I like to do is always draw a picture of it. It's kind of a sketch, if you will. So 5, 3, that would be over 5 up 3. That might be somewhere in here. So I'd like to do it similar to this. Here's 5. Here's 3. And then I like to put the coordinates over here. So this is 5, 3. Ooh, now negative 10, negative 6 is going to actually be way over here. So it's going to be on this part of the axis. So we'll make this part negative 10. And then the negative 6 part would be down here somewhere, negative 6 maybe. So this point down here would be negative 10, negative 6. All right, now what I want to do here is find just the slope of this line. Let me make it in purple for you here. So the slope of the line that contains these points, I just want the slope. Let me see if I can make that a little bit better. Okay, so this is what we're trying to find, is just the slope of that line right there. Now all we need to do in order to do that is use the slope formula. So the slope formula we call it M. So M is going to be the change in y. So I'm going to write y2 minus y1. And we divide that by the change in x. So it's going to be divided by x2 minus x1. Okay, so it's essentially, this is the same x and y coordinates, and this is another point. So over here, I can label these for you if you want. This could be x1, y1, and x2, y2. It doesn't matter which ones are the ones and which ones are the twos. It just matters that if you put a 1 here, you have to put a 1 with the other one. So in this instance, then, it's going to be a -6 minus 3 divided by a -10 minus 5. Okay, so now we calculate that. That's going to be a -9 over a -15. Sorry for the writing. I'll get better as we go through with this. And so that would be, if I divide each of those by 3, that's going to give me a slope of 3/5. And that looks about right. So I knew that over here, I needed to have a positive sloping line on my graph in this direction over here. And then I know that it was actually going to be a positive 3/5, or I know it's going to be positive. Now, it doesn't matter if the direction or which point I put first. So notice that we could have also calculated this to be, let's see, instead of the -6, what if I used the 3? So it'd have to be 3 minus -6 divided by the other x coordinates. So with the 3 is the 5, so I got to put a 5 here minus a -10. And what we get here is just 9/15, the positive version of it, which is still 3/5. So we're good. So the slope of the line containing the point 5,3 and -10, -6 is 3/5. We could write it like this. The slope is equal to 3/5. And then we can box that in. That would be our answer. Okay, let's look at some other things pertaining to linear functions. So a linear function, we're going to call it f. So this is just going to be right here, the name of the function, is any function of the form y or f of x. Either way you want to write it. This is just using the y coordinate. This is using function notation. It's equal to mx plus b, where m and b are constants. So we're saying that those are numbers, essentially. And x and y, or x comma f of x, is any point on the line. This form, y equals mx plus b right here, is known as slope-intercept form. So whenever you see slope-intercept, you're going to think of y equals mx plus b, because that is, m is the slope and b is the y-intercept. Okay, linear equations we see right down here may also be written in the following form. So we've got point slope form, which means we need a point and we need a slope. So in this instance, your slope is m and your point is x1, y1. And this is the form that you would see that equation written in. Standard form is ax plus by equals c. A, b, and c are integers, but a and b cannot be 0, or it won't be a line. So what we notice in all of these is that it's a y to a first power, x to a first power, y to a first power, x to a first power. X and y here are both raised to just a first power. So that's how we know that they are actually linear. We have x to a first and y to a first. So if we look down here at example 2, and we want to know which of the following are linear functions, let's just see what we would have here. So if I look at A, I see y to the first power is equal to 2x plus 1.4. So this one is a linear function. We're going to make a note of that. I can type it up actually right here. We will say yes, linear. And the next one y squared is equal to 2x plus 1, that one is not linear, and that's specifically because of the squared on the y. So this y squared right here is what's making that not a linear function. That one's actually a quadratic function. If we look at C, we see that we have 3x plus 7 is equal to 2y. Since the x and the y are both raised to the first power, this one is linear. D, you might be guessing right now, is not linear, specifically because of the squared. This one is a parabola that opens up, actually it opens down, but it's not linear. It would be a parabola. This last one is linear. Specifically, you see that you've got y to a first power, and over here, you have x to a first power. So now in this problem, it also wanted us to specify what the slope and y-intercept were if we had it. So we look at part A here, y equals 2x plus 1.4. Well, what we notice is it is in slope-intercept form. So in this one, the slope is going to be 2, and the y-intercept is going to be 1.4, or we can write it as over 0 up 1.4 as a point with coordinates. The other one that's linear is part C, but what we notice in part C is that it's not in slope-intercept form. So we actually need to get this one right here in slope-intercept form. Well, I have a 2y. I just need to divide everything by 2, and that will put it in slope-intercept form. So in that case, I would get 3/2 x plus 7/2 is equal to y. And this then, now that I've got it in slope-intercept form, I know that this right here is my slope. So the slope is 3/2 and the y-intercept is 7/2. So let's jot that down real quick. All right, and then the last one that we have is part E. This one is actually in point slope form. So in this one, what we notice is that the slope is -4/5. There's a negative sign there. Let me put it like that. This one actually goes through the point -2, 3. So I'm getting the -2 because if you look at point slope form up here, it's x minus x1. So in order to make this the plus right there, this tells me that x1 actually has to be a -2. And then this one is y minus y1. Since this is -3, that tells me that y1 is 3. So I have a point and a slope, but this point is not a y-intercept. So I'm going to make this equation and convert it into slope-intercept form so that I can find the y-intercept. So in doing so, this would be y is equal to, I'm going to distribute the -4/5 and add 3. So it'd be -4/5 x. Distribute this -4/5 right here to the 2, right there. So that's going to give me a -8/5. And then I'm going to also add this 3 to each side over here so that I get y all by itself. So this would be +3. Finishing it out then, this would be a -4/5 x. And I'm going to write this as -8/5. And then 3 is really 15/5. So this now shows me that this would be -4/5 x plus 7/5. So for this particular one then, what's my slope? You should be able to find the slope. You should be saying that the slope is -4/5. And this one, the y-intercept, is 7/5, or if we write it as a point, it would be 0,7/5. Okay, so that is the information for example 2. Let's look at a few more examples. So this is the last slide that I have for this video. and then you'll have a chance to practice this on your own. So perpendicular lines, these are just kind of friendly reminders. I'm sure you've heard this at some point, but you might not remember it. So we're right here. Perpendicular lines have opposite reciprocal slopes, and parallel lines have the same slope. So in this instance, if we're talking about, so let me just make a little note right here. So if we have a slope of 4/5, then the line that would be perpendicular to that would have a slope of opposite. So since this one was positive, this one's going to have to be negative. And then the reciprocal means that you flip the fraction. So those two numbers, 4/5 and -5/4, are opposite reciprocals. So if there were lines with those as slopes, we know that they would be perpendicular. Parallel lines have the same slope. We already talked about this. Slopes of lines measure the vertical change relative to the horizontal change. So common phrases are rise over run or delta y divided by delta x. And then the other thing that we'll talk about just briefly here and then more in detail later is that all lines actually have an independent variable, which we call the input value, a dependent variable, which we call the output value, a domain, which is all of the inputs that we use for a particular function, and the range is all of the outputs that we use for a function. So we'll talk more about this later, but I just want you to start kind of recalling that from memory. All right, so let's look at examples 3 and 4 here. So example 3 says, find the equation of the line that passes through the point -2, 4. So again, if we draw this out right here. So -2, 4 might be somewhere over here. Here's -2, and then we might put 4 maybe up here. So it's got to go through this point, but it needs to be perpendicular to this line over here. This line is in standard form because it's a 2x, actually it's just an equation. It's a 2x minus 3y plus 15 is equal to 0. So that one's just an equation. It's not even in standard form. So what we need to do is probably convert this to slope-intercept because I'm interested more in the slope. I've got a point right here that I know the line has to go through. What I don't know is the slope. But I do know a relationship up here about perpendicular slopes. So if I can find the slope of this line, I can use this information up here about perpendicular lines to find the slope of the line that passes through the point -2, 4. All right, so let's start converting this one. So we know then that 2x minus 3y, that's going to equal a -15. So I essentially subtracted 15 from both sides. I'm solving this equation for y, so that means I'm going to subtract 2x. So this would be -3y is equal to -2x minus 15. And then we need to divide by 3. So I get that y is equal to, I'm sorry, divide by -3. So it's going to actually be 2/3 x plus 5. See if I can make this a little bit better for you here. This is supposed to be 3. All right, well, if it's -2/3 x, let's see, did I do this right? Let me double check. So I subtracted, I get that, and then I divided, so I should get a positive 2/3. Good. So the slope is 2/3. So now if I want the perpendicular, what do we know? So then the slope of the line perpendicular is an opposite reciprocal. So that means it's going to be negative, and then we flip it, so it's going to be 3/2. So the slope of the line perpendicular is a -3/2. So now I have a point, and now I know the slope, so I'm going to use point slope formula. So remember that formula is y minus y1 is equal to m, which is the slope, times x minus x1. Okay, remember the point we're going through is -2, 4. So this is my x1 and this is my y1. That's the point. And then this right here, this -3/2 is going to be my slope. So let's put all that in. So I end up getting y minus 4 is equal to a -3/2 times x minus -2, which is going to actually end up being a positive once we get these, right? So what does this mean? This means that we're going to get y is equal to, you distribute the -3/2 to the x, so we get -3/2 x. And now I'm going to take that -3/2 right here, distribute it to the +2. So that's going to actually end up being then a -3. And then I'm going to add the 4 from the other side. So our actual equation then is -3/2 x. I'm going to write it over here where we've got a little bit more room. So we get y equals -3/2 x plus 1. And that, my friends, is the line perpendicular to 2x minus 3y plus 15 equals 0 and goes through the point -2, 4. You can plot those in GeoGebra to see what it actually looks like. So let me take you through that just real quick. All right, and our two equations, the first one that we got was 2/3 x plus 5. So I can just type that in, 2/3 x. Now be careful, 2/3, I want to come out here, x plus 5. So I had to hit an arrow over on that. We're going to move the graphics into our viewing window here. And then the other equation that we came up with is a -3/2 x. Hit the arrow over to get the x there so that it's by the fraction and not in the denominator, plus 1. There you go. So we know that it goes through that point, and then, I mean, that those lines are actually perpendicular, and then the point -2, 4 is right there, and it's on that red line. So that's what we just found out in our equation. So let's look now at our last, here we are right here. So find the equation of the line that passes through the point -4 and has a slope of -3. All right, so I like to think about what we have. Well, we have a point and we have a slope. So you'd likely want to use point slope formula. And remember that one is y minus y1 is equal to m times x minus x1. Okay, for the purposes of this video then, what we're going to say is, here's my point. I'm going to call this one x1, and this is y1. And then we know our slope is m. So continuing with what we had here, we would say that we would have y minus -4 is equal to m, our slope, which is -3, times x. This should just be x. I'm sorry, I think I wrote that wrong. It should be just x minus x1. So correct that there for you. X minus x1, which we know to be 2. All right, so cleaning this up a little bit, we're going to get y plus 4 is equal to -3x plus 6. So we are going to then get y is equal to -3x. When I subtract 4 from both sides, I get -3x plus 2. Okay, that's using point slope. Some of you might want to do it a different way, which is fine, and you might want to use slope intercept, and you could definitely do that. Let me show you how you would do that over here on the right side of this red line. So what do we know? I know that slope intercept is y is equal to mx plus b. So in this formula, what we know, I know I have a y coordinate, it's -4. I know I have a slope, it's -3. I know I have an x, it's 2, this point here. What I don't know is b. So we substitute all that in and solve it for b. So this would be then -4 is equal to my slope, which is -3, times x, which is our x coordinate of our point there, which is 2, plus b. So what do I know? I know that -4 is equal to 6 plus b. So b, this should be negative. B must be, when I add a 6 to both sides, a 2. And now, using slope-intercept, I know my slope is -3. And I know that my y-intercept is 2. So we would get the same thing, y equals -3x plus 2. Let me fix this 3 for you here. So that we actually get it kind of neat. Okay, that does it for video 1. What you need to do now is go into eCampus and try doing 5 quick problems on your own dealing with these lines. Once you get done with that, you can come back to video 2.